Hello, everyone. In this video, we're going to go over example 3 on our 2.3, 2.4 notes on the product and quotient rule. So in example 3, we're asked to calculate the derivative of the function tangent x. So we've seen in a previous section how to compute, or rather the derivatives for sine and cosine, but we haven't done tangent yet. So what are we supposed to do? Well, let's first make the observation that, and I'll write this out, first observe that we can rewrite tangent in terms of sines and cosines. Maybe take a moment to recall what that is. And all right, we'll continue together. So tangent is sine of x over cosine x. So if we want to compute the tangent of a value, we can just compute the sine divided by the cosine of that value. So therefore, then if we want to compute the derivative of tangent x, we can just compute the derivative of the quotient sine x over cosine x. So we have a quotient that we're computing the derivative of, so we need to use the quotient rule. So I'm first going to write that out, and then we'll compute the derivatives within our formula. So that, recall, the quotient rule is low, and I'll just write it out so we can remember it. So if we have a low function and a high function, we have low d high minus high d low over low low. So let's write out what that would be. So low function is cosine x, and we take the derivative of sine x, or the high function, minus high function, so sine of x, times the derivative of the low function, cosine x. And then we divide by low squared, so cosine x squared. All right, so feel free to pause the video if you need some time writing that out. So a lot of new material here, so it's important to really take your time working through these examples. All right, so now let's take a look at what derivatives we need to compute. We just now have derivative of sine and derivative of cosine. So recall, derivative of sine is cosine. And recall, we can remember that by thinking of the shape of that graph. This is sine. So the tangent lines look like this. So we start positive, which positive would be cosine, positive cosine. And derivative of cosine is negative sine. And again, we can imagine a picture of cosine starts at 1. Here, the tangent lines start at 0 and then go negative right away. So that's why we have the negative cosine. Okay, so that's all we need for computing derivatives. Now let's just combine our terms. So now in the numerator, we have cosine x times cosine x minus sine x minus sine x. So that negative here comes over, making this a positive, and I'll write it in red. So that kind of emphasizes the change of sign there. And we have that all over cosine squared of x. So to simplify this, we could just write cosine squared x plus sine squared x all over cosine squared x. All right, so now we just want to take a pause and see if this might look familiar. So in the numerator, we have cosine squared plus sine squared. So if you recall from some of your maybe pre-calc or algebra days, cosine squared plus sine squared equals 1. And there are many ways to show that. One way is, one example or justification is that we can see cosine and sine values on a unit circle. So if we pick a point on a unit circle, meaning radius of 1, the x value represents the sine value of this angle, and the y value represents the cosine value. And so we see here, if we have a point on a unit circle, then the coordinates squared is equal to the radius squared. If our radius is 1 and the radius squared is 1. So that's a cool little fact to recall. And it simplifies things for us quite a bit. I don't want to erase that yet. So let's move over here. So that numerator is 1. So then this becomes 1 over cosine squared of x. Now you might recall we have some other trig functions besides the usual sine, cosine, tangent. We have something called secant and cosecant. By definition, 1 over cosine is the secant. So another way of saying this 1 over cosine squared is to say just secant squared. So then in summary, I'm going to write this in bold and purple with a star. We have that the tangent, the derivative of tangent d by dx is equal to secant squared. And I'm going to change to red and put a nice circle around that. Awesome work.